prime over u.
Which is 4x minus 1 over
2x squared minus x.
And what's the derivative of that?
3.
That's it.
We did that, but we thought we were wrong.
It's right. Fuck indeed. Yeah. Derivative of one, derivative of the other. I could just do this all day.
Wait, what if it has like the
Well,
like
if it's
parentheses.
multiplied, then that's a whole different animal. Then you have
okay.
a product going on, right?
Oh, okay.
Right,
Yep.
but because it's positive or plus or minus in between, these are two different terms. Just like the derivative of 2x squared has nothing to do with the derivative of the x. When things are plus or minus between, its derivative comes one piece at a time. Way overthinking it. So for you guys, this is y,
Which is the derivative
and
of
y
this guy.
prime is 4x minus 1 over 2x squared minus x plus 3.
And that's the answer.
That's the answer. It's a simple, straightforward. I don't know. All right, so graphing. I'm gonna pick a graphing problem. And how many of you guys want to practice graphing?
Is it that
Me too.
point
Okay.
of diminishing? Is
The
that,
point of diminishing
I
returns?
think that's what we want
Yeah.
to talk about.
Okay.
With the graphing, right? Remember?
Yep. Okay. I can see it clear as day. So fade. It's baby face. Oh, this is good. Okay. So I want you guys to graph this one. P of x equals negative 0.2 x cubed plus 3x squared plus 6. So I'll stand that up so everyone can see it. Okay. So I want you guys to graph that sucker.
Plus b or plus 6? Oh, plus 6.
You can look over my calculator if you want. Okay. Yep. So I'm gonna clear that sucker out. So negative 0.2 x. Can you see what's going on this? Okay. Plus 3x squared plus 6. And I'm just gonna start with whatever I have. Oh, that was too damn easy. So let's go with let's start with the standard. This is a point of diminishing returns problem, guys. So with point of diminishing returns, your goal is to end up with that elongated S curve starting at the bottom left-hand corner of your screen and ending at the top right-hand corner. So don't look at the window here. I'm gonna cover that. So let me see your screens first of all. Let me see what you've got. Okay, Groovy, so yours looks like mine. Nick, what about yours? Okay, so yours, you've got a little bit more. Yours looks like mine. So we know we want an elongated S curve. So when I've got this, what I have here is the very beginning of that. What three parts of this chart do I not need?
The negative.
Here, here, and here, right?
Yeah.
So let's change our X-min and y min to 0. So if I got a window and I change my X-min to 0 and my y min to 0, one thing at a time, right?
Yes.
So now I have this. So I know that this curve is going to go up like this and over because I know that's what point of diminishing returns looks like. So I need more X? Maybe. Do I need more Y?
Yeah.
Certainly. So let's go to our window and let's change our Y max.
13.
Let's see, I have it set at 10. Let's make it 50 just for giggles.
Oh, okay.
Hit graph and see what happens. Okay, so now I've got a little more of it. I need to extend this a little more so I can see the part that I know is coming. You guys with me?
Yeah.
So I'm going to change my window once again. What do you think I should change my Y max to?
100.
100? Sure, why not? So when I graph it,
Oh, close enough.
I'm almost there, right?
Mm-hmm.
So now it's almost off the page. So I'm just gonna change it one more time, maybe to like 120. And that should be enough to give me what I want. There it is. You guys with me? So the lesson here is start with the fact that you know you don't need negative y and negative x, and then expand your x's and your y's, mostly your y's, guys, until you've got this elongated S curve that goes from the bottom left to the top right.
So then you do the second trace, right? And then you look for a value?
No, this is just graphing. So on an exam, I would want you to tell me your window. So for mine, my x min is 0, my x max is 10, my y min is 0, and my y max is 120.
Okay.
Okay.
And then from there, you just want us to draw it out
Yeah.
and then give you the
And then
window.
show me your window. Yeah.
Oh,
Can
okay.
you go over one where we indeed have to do what she just asked?
Oh,
Like
to find the point of diminishing returns?
To find the 2 points, like with the two.
Okay, so let's do this problem. So you guys are, again, you're overthinking this. So to find the point of diminishing returns, what do we do?
No,
Find
but
the first
I mean
derivative.
on the calculator.
Oh, on the calculator, you don't do it. This is pure math. Yeah, you gotta do this one by hand.
So 3 times.
0.6 x squared plus
Thinking about
6x.
something else.
Okay? Now what? P double prime
Yep.
equals,
Negative 0 or 1.2x plus 6.
now what do I do?
Set to 0.
Okay. Now what do I do?
Minus 6.
Sure. Negative 6 equals negative 1.2 x.
We divide by negative 6 both sides.
How about
No, negative.
No, negative 1.
negative
sorry.
1.2?
So negative 6 divided by 1.2.
Negative 1.2.
You get 5.
Good.
X equals 5.
X equals 5. So if you guys go back to your graph,
So this was wrong because I was doing it this way.
oh gosh, you way overthought it. Yeah.
Okay.
Yeah. So on your graph, you guys can see at x equals, let's see, 1, 2, 3, 4, 5. That's where the point, that's the point where it goes
Your
from
slope.
concave up to concave down. So my concavity is 0 at that point.
Okay.
So we're finding that algebraically, Momo. We don't have to do it graphically.
I guess
So-
what I was, I'm sorry, go ahead.
When you're graphing, were we graphing the whole, this original
Yeah,
function?
we're graphing that guy. We're graphing this.
Okay.
So
And we're finding the change in concavity by doing the algebra with the second derivative.
Okay.
Because we're looking at concavity. The point of diminishing return is about the steepest slope, and the steepest slope is this point of inflection right here. Okay, it's where your rate of growth is fastest, right?
Yes. And then so from there, that's what you just found is your point.
Of
And then you stop.
diminishing returns.
And
Yes,
then you stop.
that's
Okay,
it.
cool.
If you wanted the corresponding y value, where would you stick that x, you guys?
Back to the original.
Into the original function to get y. Nick.
she has a question.
Okay.
I guess what I was confusing that with, and what I was
Can you show
thinking
me how
about
to
asking
because I still
was
can't get
the part where you're
Like
trying
the-
to find
Oh, okay.
the
So let's see. Make sure that's plugged in right. Okay, so
you,
she went from here.
take your derivative, set it equal to 0,
Mm-hmm.
and then you're trying to solve for x. You're
Mhm.
trying to get your slope, but it's not easily
So it's
factorable.
the window.
So
Okay,
when you
then
have to
you
use a
graph it.
calculator,
What
can you
you're
show me
looking
that?
for.
Yeah, absolutely.
As
So
when you plug in that
let's
original function,
pick-
she's gonna ask you for this.
You put this and then
let's
picture
pick a
right here.
problem
Where's this guy?
and then point where the
where
X
it's
is,
not
right?
easily
The point of diminishing
factorable.
return
Which is So that's
is
when
where
that's when you take your original function, find the first derivative, then your second derivative, then you set it to 0, then you find your x.
Okay, how about this one?
Pretty simple, right?
It sounds easy.
Yeah.
But then when you go to the oh no, I can't do
Yes.
this.
Sure, it's the same thing. How do you take
So you
All
got
right.
a window. Okay,
How about
so
this?
yeah,
Y
that's right.
equals
And then so we
2x
went
to the
here.
4th
This is
minus
gonna be
6x
0, and this is
squared
gonna be
plus
120.
4. And I want you guys to find the critical values and tell me what they are. Are they maxima, minima, or points of inflection? So the
you
first
find the
step
derivative.
10.
is find the derivative.
Yeah, that's right.
So
So
8x
then-
cubed minus 12
Oh,
x.
that's what you did. So this is, remember, this is
Set
gonna
it
be
equals to
a
0?
negative
Set it equal to
0.2.
0 is
Oh, I
8x
see.
cubed minus 12x.
And then
This is not
second-
easily factorable, is it? So instead of trying to factor this and figure it out that way, I'm going to graph the derivative. You graph this,
Okay.
okay?
Then you find the point that.
The points where it
You got
crosses
this.
the
Don't
x-axis.
overthink it.
So go to
that's
your
what it is.
y,
That's what we just found.
and then we enter that
Mhm.
8x cubed minus 12x.
Yeah, of course.
8x cubed minus 12x.
Wait.
I'm going to graph it.
I'm sorry. I missed a little chunk of that.
So-
can you start?
We're looking at,
You said critical values is what you're looking
yeah,
for,
we're
but you
looking for
can't
critical
factor it
values,
out.
but it's not easily factorable.
Okay.
So instead of factoring it and messing with it that way, I'm going to graph it. So
Okay.
I know
The first derivative.
I know there's going to be at least 2 solutions, possibly more,
Right.
because of the power of this, right?
Right.
So I'm going to look for 3 places where it crosses the axis. So I'm going to go back to my
Standard.
standard, so I can go to zoom standard
Second trace.
and
Or, I'm
see
sorry,
what
sorry,
happens.
zoom.
So remember, I'm graphing the derivative here. I'm not graphing
Wait,
the
what?
original function. So this crosses
Hold on.
1, 2, 3 times. So I want to zoom in on those points. So what am I going to do to my x min, x max, y min, y max?
Wait, you wanted to find.
I want to find those 3 x values. Wherever it crosses the x-axis is where the slope is 0.
So you have to zoom in,
Yeah, I got to zoom in. So what am I going to do to my window?
shrink it.
Shrink it, yeah. Maybe -3 to 3 on x. And I don't need much in the y. I just need enough on the negative and the positive sides so that I see it cross, right? I don't need the entire graph. So if I hit graph, all I care about now is that point, and that point. Those are my critical values because that's where the slope is 0, slope is 0, slope is 0. You guys with me?
Mm-hmm.
Say that again. Sorry.
So I only care about these 3 points because those are where the slopes are 0.
Okay.
Can you show just one more time how you got? I'm here, which
Yeah, that's
is
good.
that fine?
That's good. Sure, of course it is. But if you want a little more detail, get in a little bit closer. So you can change your x min and x max to be just a little bit
okay.
closer to 0. Right, so you can get a little more detail. So remember how to do this, guys. We're going to go second, trace, which is calculate.
Value.
We're going to arrow down to 0,
Oh,
hit enter. Now let's take a look at this first one over here. So it's questioning. It says left bound. So we want to drop the cursor a little bit to the left of the point we care about.
So you're
Right.
just doing the minimum.
No, not minimum. Left bound, zeros.
Like right here. Or
No, we care about these 3 points,
okay.
not the minimum. So when I set my cursor a little bit to the left of this point, it's like dropping the left-hand side car. So there's my left bound car. See how that's going to stay put? Now I want right bound, which is a little bit to the right of that point. So I hit enter, and then I hit enter again, and it's going to converge on the solution, which is 1.2247. Blah, 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 blah. Not easily factorable.
That's a 1 point. That's point
That's
1.
one critical value.
Okay.
Now help me find the others, guys.
So you go to trace, second trace. You would go to 0.
Mm-hmm.
And then if you want the guy right in the middle, you're gonna do left bound here.
It's going to be a little above it, right?
Mm-hmm.
Okay.
Oh snap! Okay, it didn't let me.
Right bound is going to be where? A little below it,
Okay.
because it's a little to the right of it. And then we converge, and that x value, that critical value is 0.
Which is this guy right here.
That guy right there.
Okay.
Yep. And now we're going to do it a third time. This gets really old. But it's still faster than trying to factor this. So left bound, again, I want to be a little bit to the left of that point, so the cursor's going to be below it this time. Right bound, cursor's going to be a little above it. Guess, and it converges to the solution. So I have 3 critical values here. How do I test them to decide what they are?
Plug him in.
Using calculus. Plug them in where?
The second derivative.
And if the result is a negative, is it a max, a min, or a point
It's
of
a sad
inflection?
face, so that's a max.
Max, right? It's given in the shape of it. There's a max sitting right on top of that. If the answer is positive, is it a max, a min, or a point of inflection?
It's a min.
If the answer is 0, is it a max, min, or point of inflection?
HPI.
Good. It's that simple. How do you guys feel about that?
So maximum,
Have a 0 slope.
minimum.
Mm-hmm. Yep.
Just remember your.
counterintuitive, right? Because the concavity is going to come out negative, but it's a maximum.
Maximum.
The concavity is going to come out positive, but it's a minimum.
See, that's why I was getting confused.
Yeah.
But you have to think of the sign of the answer and what it looks like. That's why I draw the little happy face and the little sad face,
But you go
to
opposite
remind you that there's a maximum in a negative concavity, and that there's a minimum in the positive concavity. So everything I do is for a reason. Okay.
Question.
Answer.
So what if you get like if you just get HPI as 0, but you don't have any other values?
That's possible.
Is that DNE does not exist, or like, what do you do then?
If you had a single critical value that gave you an HPI,
That's it. You're done. Right?
that's it. You're done.
Okay.
It's just like that problem we did together. Do you guys remember this? This was out of 10.1, I believe.
I think so.
It's the one I did on the board with you guys, either this morning or yesterday, depending on which class you took me with.
Mm-hmm.
It was the x cubed minus 6x squared plus 12x plus 1. So those of you that have your pictures, this has an HPI, but it doesn't have a max or a min. So I'll show you. This one that we did on the board this morning,
Yeah.
this has
No,
an
you're good,
HPI,
babe.
but it does not have a max or a min. So you'll get one critical value, and it'll come out with a 0 concavity, which indicates that it's an HPI. Okay? Same thing for you, Memo. What else, guys?
So, one, steps. I'm more of a steps girl.
I
So,
know you like steps.
okay. So one, find your first derivative,
Mm-hmm.
then find your second derivative. Right.
Mhm.
Set it to 0.
Mm,
No.
no, you only do that when you're finding the point of diminishing returns.
Oh, okay.
You
Okay.
go straight to the second derivative.
Okay. Okay.
But
The first one.
if you're finding maximum, minimum, and points of inflection, excuse me, I inhaled my gum
Oh.
and it's burning. Holy shit. Take the first derivative, set it equal to 0, solve for x. Then plug those x's into the second derivative, and they'll tell you what those critical values are. Are they maxima? Are they minima? Are they horizontal points of inflection?
Okay. Okay.
Or in that case. Does that help you guys?
Yeah.
Okay.
That's better.
Yes, that's all I needed. Thank you.
Okay. Tyler?
Yeah. Making sense.
Yeah?
Yeah.
Yeah? Nick? Chandelier?
Makes sense.
It makes sense. Brenda? Memo?
Yes.
So what else do you guys want to know?
Homework question.
I
I know.
I have answers for homework questions. Sure. What's up?
11.1 number 43 is where I got confused.
Okay, let's see it.
And I have like I have Cengage, so my questions online is different than the actual book.
That's okay. You can find it in here.
It's what I found out with Emily yesterday. That's why we were like stuck on these.
Did she tell you what I told her? How to download like the book that she uses?
Yeah, but I just want to make sure I'm doing it right. You know. What
Where's
I mean?
your problem?
Number 43. It's this. Is it marginal cost? Oh wait. I'm sorry. It's 11.2.
2. So it's the exponentials.
Yeah.
Okay.
Yep, like this guy. See,
Ah.
yesterday we went over this, but you put a S, comma, the little.
Oh, because I was integrating.
Yes,
You're
but then
going the other way here. You're taking a derivative. Because it's
That's
asking
why I'm
for the
confused.
rate of future value. If it asks for a rate of change, what is that shorthand for, guys?
Derivative.
Yeah, derivative. This is going
Rate of
back to
change.
chapter 9. Rate of change is derivative. It's how fast something is growing.
can you
Okay.
show me that,
Yeah.
please?
S
Sorry.
equals PE to the 0.1 n. Okay, so n is our variable. So this is really s of n. Okay, equals p e to the 0.1 n. And the reason is it doesn't matter what you start with in terms of principal. This is the amount you've invested. This is your APR. This is 10% annual percentage rate. So this is the continuous compounding interest formula. Okay. So for various reasons, I don't know if you guys want to know the why we use this formula and not some normal interest formula. I can show you that, but it won't help you understand this. So future value, initial investment, e to the APR times y. Y in this case is n is number of years invested. Okay, so n is our variable. Doesn't matter how much you invest at the beginning. All that matters is how long you invest it. That tells you how fast it's going to grow over time. Groovy?
I'm confused why you put s to the n inside.
It's not s to the n, it's s
Or
of n, just
s
like
of
f
n.
of x.
Oh, okay.
So s is a function of n,
Okay. Okay.
Okay.
Yeah.
which makes p a constant. All right, so what's the derivative of s?
0.1
Mm-hmm.
p
Mm-hmm.
e to the 0.1.
Tell me why you needed my... You just did it. That's it. Don't overthink it,
Okay.
Brenda. It's the same as every other problem. You're getting lost in the words. If it asks for rate of change, that means
Plug in.
the derivative. If you're given the derivative and you're asked to find total something, you're integrating. Okay?
That's the part I needed to know. That was my next question, because I don't know when to find the derivative and
And when to integrate.
Yeah.
So if
That's
you're
where I was
given
getting
this
stuck.
and you're asked to find the total, you're integrating. If you're given this and asked to find rate of change, you're taking the derivative. So marginal cost is the rate of change of cost. Marginal profit is the rate of change of profit.
Okay.
Okay? And those are derivatives.
Yeah.
And to get back to total cost or total profit, you would integrate. So on your tattoo, those are the circles right here. Take the derivative to get to the marginal. You integrate back to get to the total.
I was reading this, but I just didn't know what it
And
means.
now you know.
Okay.
Does that make sense?
Yeah.
Awesome. Tyler?
So I have a question on number 17.
Okay.
11.2.
Okay. What does that look like? Oh, is that e to the negative 1 over x squared and
Yes.
plus e to the negative x squared? I think I
So-
did this one on the board, man. You're like, I hate you.
And take a picture of it or write it down, apparently.
Well, okay, so let's start with the e to the negative 1 over x squared.
That's the one I'm struggling with.
Yeah. So let's just look at negative 1 divided by x squared. That's certainly not pretty, but can we make it pretty, guys?
Yeah, bring the x up.
Bring it and make it
Negative
what?
2. So negative 1 x to the
Yeah.
negative 2.
Negative x to the negative 2. So let me rewrite this as e to the negative x to the negative 2. F this side-to-side notation crap. It's so hard to see what's going on, right?
Yeah.
But this makes it easier. So if this is your y, then what's your y prime?
2 e.
What's the derivative of this? Positive 2x to the...
Oh, negative 3. And then e to the negative x to the negative 2.
Done.
Wait, where did you get the x to the negative 3? I'm sorry.
Remember, when you have e to the anything, you take the derivative of the anything times the original function. So what's the derivative of negative x to the negative 2?
That's 2. Well, I understand where he got the 2, but the x to the negative 3.
When you take a derivative of something, you drop the exponent down and subtract 1 from the exponent.
Okay.
So positive 2x to the negative 3.
Oh, okay, okay.
For whatever reason, my mind, like... I don't
Because
know,
we've
I
been
think it's
going
like the-
backwards
yeah.
for so long, it's hard to go forward again. It's like jamming your car into reverse when you've been driving.
It's the n
It doesn't
minus
feel
1,
good.
right?
Yeah.
The
It
derivative
doesn't feel
is
good.
subtracting 1 from the exponent.
Integral.
Integral is adding 1 to the exponent.
That's right.
Derivative is subtraction from the exponent.
Right.
Integral is addition.
And multiplication to the constant coefficient is also part of the derivative. So when we integrate, we divide instead to undo it.
Oh yeah.
So that's what all those elements in the integral are for.
Opposites.
It's literally the antiderivative. This is actually what we're doing right now is the antiderivative. We're undoing the derivative.
So then, if you were to figure out this one, would you do also plus whatever you found here, and that's your answer?
Because the derivative of this has nothing to do with the derivative of that. Because
Oh,
they're
okay.
separated by pluses and minuses.
But if it was the dividing or multiplying, then
you'd
you
have
do
to treat it
product.
like a product or a quotient.
quotient, okay.
Exactly.
It's
Nick,
making more sense.
Does that help?
Yeah.
What's your worst section?
The one we were doing together.
The logs.
Yeah.
The logs? Okay.
It's like everybody's words.
After 11, yeah.
Yeah.
Pick me an awful log problem.
Nick.
Pick me a bad log problem, Nick.
No, you're fine.
Come here, your work. Oh yeah, there's a jar. Pass it around.
Let's do number 20.
Is there York?
I don't know. There may be one left in there. Who knows? It's time for me to. Nope.
It's
I
okay.
suck.
I will take the Asian candy.
Yeah, they're delicious. It's time for me to go shopping again. All right. So which one did you pick?
Alright, number 20.
Number 20.
Number 20. Oh, S equals. Hi, Maria.
I was sure.
S equals natural log of.
While my hand is out.
TQ to
No.
And then parentheses T squared minus 1.
1.
And then number 21, too, please.
And number 21.
Page
All right,
zero.
patience.
Yes.
All right, chickens. So when you stare at this, what do you see?
I see natural log.
You see a natural log. That's good. So if you're asked to
Right.
take a derivative, which you're eventually going to do, you need to make this a natural log that you can bite into. If you bite into this, will you choke?
Yeah.
It's way too complicated. It's a product.
It's like giving me
Okay.
to a baby.
So yeah, don't do that. Yeah, let's stick with the pureed vegetables, you know, like pureed chicken hearts or whatever it is you give your kids. Ah,
I don't want kids.
I don't even know, right?
I have a cat.
Well, I
I'll
have
go
a
with
cat.
that.
That's all I need. So, is there something on your tattoo that helps you split this up? So this is Nick's worst
Yeah.
one. So I'm going to let him find it. Nick, what's on the tattoo that helps you split this up? We know it's a product, right? So we're looking for natural log of a function times a function. Is there anything on the right-hand side that can help you, Nick? That's the left-hand side, Maria.
You're in the right path, Nick.
You're in the right path, Nick, but you're looking for natural log of a function times a function. So let's just run down. It's not a product or quotient. It's not a power. It's not natural log of E. Is this what you need?
Yeah.
Good.
Mhm.
So just run down and find what looks like it. Don't just let your eyeballs wander. Be deliberate. And you're looking for specifically a natural log. Good. So natural log of what's my first function?
T to third.
That's it.
T cubed.
Sorry, Nick.
And what do I do in the middle? Add or subtract?
Odd.
Multiply.
No multiply.
I don't multiply. Look at it
He was
again.
right. He
Nick,
said
you,
add.
yeah, he said add.
Yeah. Okay, good.
You're right, Nick.
Natural log of t squared minus 1. Okay. So now it's my derivative. I've broken it up into easy derivatives or easy derivable bits. So what's the derivative of this? So now we go back up here after every step and we check, is this something that I can easily do with each one of these? And the answer is yes. So what's my derivative of this guy?
Nick.
3.
Mm-hmm. 3t what?
Plus Oh, 2 square
And what do I divide that by?
by t cubed.
Exactly. So you're using this process now, right? Over t cubed plus, now do it again.
Okay. 2t
Mm-hmm.
minus 1. Okay. T squared.
And you're done. So one step to split it apart, one step to take the derivative. Have you been overcomplicating these?
This is where we're getting stuck. We get here and we can't do this part.
Now, after every step that you use to take shortcuts, always go back to your original and say, now can I do it? Is this an easy function that I can easily take the derivative of? And then you just follow the steps, u prime over u. So whatever this is, take its derivative and drop it over itself. Whatever this is, take its derivative and drop it over itself.
I have a question.
I have an answer.
So if I looked at the top one.
Mm-hmm.
I looked at the top one
Mm-hmm.
and I said, hey, ln of this, and I looked at this,
Mm-hmm.
okay? Because this could be my u.
Yep.
And I said, I've got two things in there,
Uh-huh.
and I go u prime over u. So I
Good.
take t cubed. I take the derivative of that, that's 3t squared over t3.
Mm-hmm.
Then I look at this one, I can easily get lost there. But I take the derivative of that,
Okay.
so that's 2t, so that's just 2t, and then over
t squared
t
minus
squared
1.
minus 1.
So what do you do in between those though?
Now that is my issue.
I mean, you
Your
did it
problem is you're taking the derivative before you split it apart.
right.
Yeah.
You're ignoring the rule.
Split it apart before you take the derivative.
Okay.
Okay. There's another way to do this one, guys. What is it? These are not bound by powers, so what can I do? I can distribute. So I can rewrite this as s equals the natural log of t cubed times t squared is t to the 5th. T cubed times negative 1 is negative t cubed. Can I easily take the derivative of that?
Yeah, I can do
Yeah.
that.
What's my derivative?
So that is
5t to the 4th.
5t to the 4th minus
3t squared.
3t squared
Yeah.
over
t fifth minus 3.
minus t cubed. This is the same as that, guys.
But then you don't have the plus.
It's a different form.
You would accept that.
Oh, hell yeah, I would.
But it doesn't
Absolutely.
have a plus.
That is the same as
Oh,
this. It
minus
just looks
and
different.
minus is a plus.
No, that is not what this is.
Okay. But I'm getting two minuses and I just got, how did that,
All right. Give me that back.
okay. I mean, I like what you did there. That makes more sense to me than this one. Because I'm doing like two different steps.
This, we need a common denominator, right? This has a common
Yeah,
denominator. So
yeah.
I'm going to give this a common denominator. This needs t cubed divided by t cubed to get the common denominator. This needs t squared minus 1 over t squared minus 1. So when I distribute this, I end up with s prime equals 3t squared is going to be 3t to the 4th minus 3t squared, right?
That's so confusing.
That's this.
That's
Hang on. 2t
away.
times
Yeah.
t cubed. 2t times t cubed is 2t to the 4th. And then my common denominator is t squared minus 1 times t cubed. So I want you to look at this. What's 3t to the 4th plus 2t to the 4th? 5t to the 4th minus 3t squared.
Yeah.
And if I distribute that t cubed, I'm
Okay.
going to end up here.
So I like
It's-
this one because it's more easier for me to think ln
Okay.
this and ln with that because I can do that.
There's yet another way to do this.
Yeah.
Just
Yeah.
not to terrify you guys.
Yeah.
But I can do u prime v plus uv prime
Is that the
on the
product
top,
rule?
and then
then
this
go to the
on the bottom, and that's still the right answer.
So you
Mm. Magic girl.
Would that be the product rule in between you're doing?
You would
is that
use
what
the
you're
product
saying?
rule to take the derivative.
Yeah.
That's like you go in beast mode though. Like we can barely read the stuff you gave us. Like
But I'm saying that there's multiple
Yeah,
ways to do
yeah.
this correctly. If I only give you one way, that's not
Yeah.
giving you
But
guys the
correct.
ability to
Don't
think
uncompli-
for yourselves.
But don't complicate it.
I'm not complicating it, but I'm saying if your brain works a
Yeah.
different
Oh,
way,
Yeah.
you can
Then you
still
can
do
still
it.
do it.
You can still do it. I'm not stopping you
Yeah.
from doing it your
Okay.
way.
But because
Hey.
you had a plus and then we had a minus, that kind of made me think, oh, did I get it right?
That's right.
See, that's the.
Wait, can
So
you do
just get
the?
to join us now.
Yeah.
You get me at 2 all by yourself. I'm kicking their asses out, but until 2, you're with them. I don't know if you want to like come sit. There's still a
Yeah.
chair.
yeah.
Can you do
Sit here on that side.
Here, he's just perched. So we'll turn this way. Sorry, Tyler. Sorry.
Can I have
Can I
the
have
one with
21?
the minus?
Yeah, can we
one?
do 21?
What? I'll give these to you.
No, I think that's for.
Yeah, I'm not the first one. I like the first one.
You like
So-
the first one?
Yeah.
That one makes you happy? Okay.
I mean, I
Alright.
like this too, but it's like.
21. You have to make it
21.
pretty, yes.
Natural log of t squared plus 3.
Uh-huh, over.
The square root of 1 minus t.
1 minus t. Okay.
Oh, nice.
So, Nick, since this is your weak spot, I'm going to make you help me with this. What can I
Okay.
do to break this apart? So, again, we
So-
start at the top.
Take the bottom all the way up.
I can. That's kind of going to be a mess, though. Is there an easier way? Look at your tattoo. Look for shortcuts on the tattoo. So right now I'm looking at natural log of a function over a function. Oh,
Keep it close.
Why is it that I just overthinking all these things?
mm-hmm. That's okay. Most of you are.
Yeah, so you're in the LN section.
You're good.
It's one of those 4 probably.
Okay, think about it.
Oh, they have
So,
chickens.
look at,
Lined
like,
up
when
in
you
a
look
row.
at it,
Uh-huh.
there's that division on top, right?
Yeah.
So when you look over here,
This is
which
Where's
one
the
do you
division?
think you're
I
gonna
was wondering
use?
the second one,
Exactly.
I wasn't sure.
Right,
Yeah.
because basically what we've got here
But the
is
problem
some stuff over some stuff, right? So don't look at the trees, look at the forest.
Yeah, but the thing is, I'm guessing it's not like.
Yeah.
You
So
don't
how do I
understand
know-
why?
Yeah, it's not because I know. It's just-
But is it because it intimidates you? Is that what you're
Yeah,
looking
I
at?
think
Okay.
So stop looking at the trees and the leaves and start looking at the forest. It's some junk over some junk. That's all you care about. So
Okay.
how do I split that up? I do the natural log of the top junk.
So that would be t squared plus that 3.
That's the
Oh,
top junk. And what do I do with,
minus.
yeah, natural log of the bottom junk.
Uh-huh.
So you don't even have to know what the top junk and the bottom junk are, right?
Mhm.
So that would be t.
So this is 1 minus t to the what power if I make it pretty. So one step at a time here. Natural log of t squared plus 3. God, my upside down writing is crap. Minus natural log, Jesus Christ, of 1 minus t to the what power, my guys?
1 over 2.
My dudes. Okay, now is there a little thing that can help you bring powers down so that you have an easy derivative like this one? So look at your tattoo. Hint, hint. How do I get powers down? How do I deal with powers on natural logs? So I have natural log of some junk to a power.
P.
P is a power.
You're looking at the right place. What's P? What do you see P in here?
P for
So
power.
here, but
So what do I do with that 1/2?
So you're gonna convert it. You got this, Nick.
You got it, Nick. It's still a squared, Jessica. So, hasn't changed.
You're not getting
What do I
points here.
do with that 1/2? Help them out.
yeah, I can see it right here.
So
okay.
don't overthink
So
it.
okay, so
What's P on this page?
1 over 2
So where does the 1/2 go?
goes all the way to the bottom.
It goes in front. 1/2 natural log of 1 minus t. Stop getting lost in the numbers and think of these as little tidy packages. This is your M, this is your P. I rewrite this as P natural log of M.
Yeah.
I don't care what P is. I don't care what M is. That's where that stuff goes. So now I have natural log of some junk. Is that easy derivable? Natural log of some junk. Is that easy?
Kind of.
Lovely. What's my derivative?
2t
Mm-hmm.
plus. No, over
You kill it,
t
killer.
squared
You kill it,
plus
killer.
3.
That's the first one. Second one. 1/2 is now a constant coefficient. It goes along for the ride. So
Times 1.
Is 1 over.
What kind of
minus
one?
t.
Negative 1.
that's a -1 for the derivative over
1
1
minus
minus t. And all you have to do is resolve those negatives and make it positive, and you've simplified it fully.
But we don't have to for the exam, right?
No, I mean, I may say simplify to a workable point.
Okay.
Here you go, hon.
Thank you.
Can I ask a quick question?
Yes.
Something that I was trying to get at yesterday, but
Did you
couldn't really get
understand?
the words
Get the
out.
words out.
So, if
You're
this
overthinking it.
natural log, even on the last one that we had,
Mm-hmm,
if it wasn't here, or if it was just applied to, let's say, the denominator,
mm-hmm.
is that when we'd actually use this quotient rule
Aha.
up here?
So, like so.
Oh,
Watch.
there's a different one?
Natural
Gotta
log
be kidding me.
of 4 minus x cubed divided by x plus 6x squared.
Yes.
Is that what you're talking about?
Yes.
That's a quotient, guys.
Yeah.
So
As
because
a
like the
quotient.
natural log isn't applied to both,
The natural log doesn't
Then I
tie to both of them.
can use the
Yep.
quotient rule.
Yep. So
Wait,
you guys know what's coming.
That's the one.
Here's my u.
Okay.
And v.
Here's my v. So what's my u prime? You guys know how to do this. It's a natural log, so you're going to use the natural
so
log.
U prime
Over you.
over v times v.
Over
The
4
original.
minus x cubed.
And what's my v prime?
Oh. Is that times?
Yeah.
12x. 1 plus 12x.
Plug
and
and chug.
then u prime times v minus u.
You like that? It's
times
like a
v.
child wrote that. Quotient. Looks like Calvin.
U
Mm.
prime over minus 3x.
Calvin and Harris?
Calvin and Hobbes.
Or shit. Close enough, you know.
So this becomes quotient.
So then we just plug and chug. We have our u prime. We have our v. We have our u. We have our v prime. And v squared is just this squared.
Even if it was flipped, even if this
Yeah.
guy was in the bottom, you still
Yeah,
do the whole.
You would
okay.
still do the whole thing because the natural log isn't tied to
Then
both,
tied
so
to
you
both.
can't split it apart.
Can we do one with E? I hate E. The E
Are
one.
you guys all okay with E?
And quiet.
You okay?
Am I the only one that doesn't
You
get
guys-
E?
Nah, everyone hates E. You're not
Thanks for
alone.
asking this. I was
Yeah, right? Watch it be the first problem on our exam.
You want it?
No.
Oh,
that
okay.
that clears it up. I asked it yesterday and I was like, I can't even communicate how to ask the question, so like I feel unprepared.
On our, what, Monday and Wednesday class?
Yeah.
I feel like some of them are so advanced that I'm just like so shy to ask questions.
That's me.
And I'm
I'm
like,
like,
I'd rather
oh,
just go see
I
her.
am so behind.
See what I mean? Okay.
What is it for? E
This is much harder than anything I would give you on the test, you guys.
This is really bad.
minus
It's not though.
2.
Squint.
This is
You find the
Oh.
derivative of
Two.
that one.
No, it's a U and then a V, so it's a quotient.
It's a quotient.
So this would be quotient rule, right?
Yes.
U.
Here's my U.
This is my v.
Here's my V.
My u prime is going to be
One thing at a time, guys. What's the derivative of that? So I'm just going to cover everything else.
12x.
times
Squared.
4x cubed.
E to the 4x cubed. Nayeli, way to go.
Minus 2.
Minus 2. And what's V prime?
1 plus 28x cubed? Or
How about
32.
32x cubed.
You know what?
plug and chug, guys. It's quotient. So you use u prime v minus u v prime over v squared. You have all the parts.
Okay.
So we're still doing what we've always done, where we
Yeah.
look at it globally first. Like,
Yeah.
what do you have to do globally, and then once you figure that out,
Yeah.
then you follow each individual rule to try to get
For each
to the
individual
global
part. If this is an e, you're going to use the e process to take its derivative. This is a straight derivative, so don't overthink it. The derivative of negative 2x is just negative 2. This is all straight derivative. Derivative of x is 1, derivative of 8x to the fourth is 32x cubed.
So what if you had like this guy and it was like another x up here? Are you gonna do that to us?
No,
Okay. Just wondering.
but just for shits and grins, since you said it,
Okay.
Let's do it.
I mean, I don't know what to expect,
3x
you know.
to the fourth. What's the derivative of that?
4,
It's like
Or
right?
4. That's the first step.
Junk.
What junk?
That.
E.
Junk.
All that junk. E to the 3x.
And then.
The derivative in the
three-
inside.
of the inside.
Oh yeah.
And then
yeah.
you,
To
this
the-
is like the chain rule, right?
This is exactly what this is.
Yeah, but then the E disappears.
It does not.
Oh,
It would be
It's
3x. Yeah, no, 3e to the
3x.
3x.
Done.
Square.
Done?
No, done.
Where's my square?
You tell me. Look at the
Oh, because
tattoo.
it's, yeah.
Oh,
The derivative process for e to the u is u prime e to the u. You
Oh,
have to
yeah,
follow
this
the
is
right process.
derivative.
So we're using two processes here. Globally, this is a d out dn. It's a power rule or chain rule. Locally, on the inside, dn is going to use e to the u to take its derivative. So you've got two things going on here.
Yeah.
Can I ask one last thing before we leave?
Gosh, of course. You guys still have 10
Admin
minutes.
building.
Oh, okay.
Are you
Thank
taking
you.
off?
Yeah, I have to go to the admin building.
Call me if
for-
you need me tonight.
I will.
You've got my number.
Yes, thank
Just
you.
one-
All right.
Can I just have a quick?
Oh, of course. You can. I'll hand all of these to you,
Okay.
and you can take pictures of whatever you need. And I think those go to Chandelier because
Yeah.
I think you asked for them, right? And Nick,
I'll
you as well.
pictures.
You've got your pictures. Okay.
Thank you.
Which one?
This one.
Oh,
You gave
Okay.
me a test and I was not
let's
able to
do it. This is the integral of x squared minus 1
Over.
over x cubed minus 3x. That's a lot of threes going on. To the third power, and this is with respect to x. Is it pretty?
No.
So I'm gonna flip that over so you can't see it. How do I make it pretty?
Take the whole thing all the way up.
Drag it up. I drag it up by the exponent. So what changes sign, guys?
The exponent to -3.
Yeah, so I've got x squared minus 1 times x cubed minus 3x to the negative 3. Now, Chandelier, which integral is this? 1, 2, 3, or 4?
4.
Why?
Because it has a negative exponent.
But what does number 4 need to have? Specifically a -1
Oh.
and no other.
Where
That's
got
what I was
lost.
confused yesterday,
Okay,
too.
That's where I got lost there.
Yep. Okay, so which one is it now?
1.
It's not 1.
It's not, it's 2.
It's gotta be 2.
Sorry.
Right.
And the reason is we have a function times a function to a power. So stop thinking of these as u's and start thinking of them as function, function, power.
Okay.
Function, function, power, and that power is not -1. That's the only limiter here. All right?
Okay.
So now, what's the next step?
Your u and your identifying your u
Find
and
the
your
u.
u prime.
So because we're working with integral number 2, our u is tied to our exponent. So what's our u here?
X cubed minus 3.
And what's its derivative?
3x squared minus 3.
This is what we want.
That's what you want.
X squared minus 1 is what we have.
That's right.
I think I feel like
So then can you do
What is it?
3
So from there,
integrals are
X
easier for me
squared
than
minus
So you don't know what to do?
no.
Okay.
So
Okay.
So since you already have, this is what you want, but in that case, you have this.
Right.
So what are you gonna do
So
to
just
get?
look at the first term and see if it works for that. How do I make x squared look like 3x squared? What do I
Multiply
multiply by?
Multiply by 3?
Good. And if I distribute that, will I get what I want for
Yeah.
the second term?
Yes.
Good. So if I just multiply by 3, I'll get what I want. Can I just multiply by 3, Chandelier?
No.
I don't
If
know.
I multiply by 3, I make everything 3 times bigger. What's the only thing I can multiply by and not change a thing?
3 over 3.
You divide by 3 and you multiply by 3.
Yes. That hasn't changed anything. 3 divided by 3 is 1. 1 times anything is still the same. Okay? So now I have x squared minus 1 times x cubed minus 3x to the negative 3 with respect to x. So now what do I circle? I want 3x squared minus 3. So circle everything that gives us that. Do I need this 3?
Yes.
Do I need this x squared minus 1? Do I need this 3?
No.
Good, so where does it go?
Goes
Out. And if it goes out, put a 1 on top of it because it was on the denominator to start with. It needs to stay there.
Right.
So now I have a 1 over 3 outside. I have 3x squared minus 3 because if I combine those,
You distribute it.
distribute it, times x cubed minus 3x to the negative 3 with respect to x.
Okay.
And
Cool.
now what do I do? So our goal was make it look like the template. We did it. We have exactly u prime, u to the n.
Okay.
So now what's my integral? Just
The
fill it in.
1/3 goes along for the ride.
1/3 goes along for
Your
the
command
ride.
disappears,
My command to integrate disappears.
and then it's gonna be x third
Mm-hmm.
minus 3x
Mm-hmm.
negative 2
So n plus 1, negative 3 plus 1 is negative 2
all
divided
over
by negative 2
plus
plus
k.
k.
Damn it.
And we're done.
So once again, x.
So the steps rule you. Skip the steps, you'll get it wrong. Don't skip the steps, you can't fuck it up. You can't fuck it up.
And then we gotta solve from k. If
Well,
it's asked.
If it's an application problem, yes, you must account for k.
Yeah.
If it's a pure math problem like this, you're
Yeah.
good to go. Yeah, you're done.
Okay,
Because there's nothing else you can do.
That's what I needed.
So what if it's two different functions, like the ones that you showed?
Aha!
Two different things.
How about this? So Nayeli asks a great question here. What if it's 3x plus 3e to the 4x?
Wow.
And we integrate that with respect to x.
Oh shit, okay.
You're gonna
So,
integrate
which
these
integral is
separately,
this?
right?
1, 2, 3, or 4?
Uno.
Which integral is this?
3.
So we have two different things going on here. So I'm going to split them up.
You can do that.
Oh, hell yeah, I can do that.
Okay,
Tell me
okay.
why I can do that. And show me where on your tattoo it says I can do that.
Bottom.
Where?
This one.
Yeah, because addition and
Okay.
subtraction, just like addition and subtraction when you go through and take derivatives, that separates each term and each term has its own process. So with these, each term has its own process. Same thing. So we're going to use integral number 1 here. And we're going to use integral number 3 here. So remember what I said, with integral number 1, you make it pretty, you perform the integral. This is ready to go. What about this one? We must go through the steps.
We found the derivative. The u.
What's our u?
4x.
And what's u prime?
4.
And what do we have?
A 3.
We have a 3, we want a 4.
So divide and multiply by 4.
Yeah.
See? Sí está bien? Sí.
So I still haven't integrated this, so the command to integrate stays. You guys with me?
Yes.
And I'm going to add
4 over 4.
4 over 4 times 3e to the 4x with respect to x. Circle what you want.
We want a 4.
We want a 4. So what do I kick out?
3 4s.
Good, so this becomes the integral of 3x with respect to x plus 3/4 integral 4e, I can do this, to the 4x with respect to x. Now, is this one ready to go?
C. No.
Is this one ready to go?
C.
Because we have u prime e to the u. And this is just a straight integral. So what's my integral, guys? 3x to the what?
Squared over 2
Over 2
plus
plus.
3/4. That guy stays along for the ride.
What happens to that 4, Nayeli?
It is
It disappears because it's the u prime. It goes away when you integrate. You go from u prime e to the u to just e to the u. Okay? What am I forgetting?
Plus
K.
K. Plus your K, killer.
That's right, k killer. So Nayeli, is this what you were talking about?
Yeah.
Awesome.
Is that something that may come?
Possibly.
Oh, nice. That is.
You guys know how to do every little bit of this.
Yeah.
You get lost in the weeds though.
Winter is coming,
That
y'all.
is true. The weeds are-
The weeds. It's weird that people are all taking pictures of my lap. Very strange, don't you think?
Oh my
It's like-
gosh.
all the phones, and I'm like, okay. No, it's fine.
I wanted to say something, but I won't.
Here you go, guys. Good times.
We all fall in.
All right.